Hello students, in previous class we discussed about inductive effect and the applications of inductive effect. Okay. So today I am going to discuss about the second application of inductive effect, that is the reactivity of alkyl halides. Okay. So reactivity of alkyl halide, they given, this is called tertiary alkyl halides because halogen which attach to tertiary carbon atom. What is tertiary carbon atom? One carbon atom which attached to another three carbon atoms. Okay. So tertiary alkyl halide is reactivity of tertiary alkyl halide is more than that of secondary alkyl halide than that of the primary alkyl halides. Okay, so because tertiary carbocation is more stable than that of the secondary carbocation than that of the primary carbocation. Okay, so now see the acidic strength of the following acid. Okay, as you know that acidic strength is inversely proportional to positive inductive effect. As the stronger electronegative group attached to the acidic group, then the acidity should be decreases. Okay, so see the given options. First, that is our formic acid, or you can call as a methanoic acid. Second, acetic acid. Third option they are given propanoic acid. Fourth option they are given 2-methyl 1,2,2-methyl propanoic acid. Fifth option they are given 2,2-dimethyl propanoic acid. Okay, so one thing is that as the more number of electron donating groups which are attached to the carboxylic, this is called COH, is a carboxylic acid group. Okay, so as the more number of electron donating group which are attached to the carbonyl group, then their acidity should be decreases. Okay, so the order of acidic nature, that is the first one, formic acid is stronger acid than that of the acetic acid. Second one, than that of the ethanoic acid, propanoic acid, than that of the 2-methyl. Fourth option, 2-methyl propanoic acid, and then that of the 2,2-dimethyl propanoic acid. So which one is the weakest acid? That is the option fifth is the weakest acid. Which was stronger acid? Stronger acid is the formic acid, or you can say is the methanoic acid. Next question. Fast reaction of KOH aqueous on alkyl halides. Okay, so in KOH, OH minus is called as a nucleophile, and in all those they are given A, B, C, D option. The alkyl halides they are given Cl. It is a living group. It is a good living group. Okay, so which alkyl halides they will undergo fast reaction with KOH? Okay, so C in the option A, it is a primary alkyl halide. Option B, secondary alkyl halide. Option C, tertiary alkyl halides. Option D, that are given primary alkyl halides. Okay, so see in the option number C, there are 3 electron donating groups, that is methyl groups, which are attached to the carbon here. So hence they will decrease as the positive charge, carbocation, positive charge on the carbon atom. Hence tertiary carbocation is more stable than that of the secondary than of the primary. Hence tertiary alkyl halides, they will undergo very fast reaction with aqueous KOH. So which one is the right option? Option number C is the right option. Okay, so next question, most stable cation. Okay, so which one is the most stable cation? Here if you see, here is CH3, CH2, CH2 positive here. Option B they are given. So option A and B, C, in option A they are given one bigger that is ethyl groups, and but here there are 2 smaller ethyl groups are there. So in this case you have to undergo some that is hyperconjugation effect. Okay, so in this case there are only 2 hydrogen which are involved in the hyperconjugation. Here there are 3 hydrogen atoms. Here is CH3, in that 3 hydrogen atom. Here are 3 hydrogen atoms which are involved in the hyperconjugation. So more number of hydrogen which are involved in the hyperconjugation, more stable is the carbocation. So here only 3 hydrogen which are involved in the hyperconjugation. No, here is no hydrogen which are involved in the hyperconjugation. Here only 2 hydrogen atoms which are involved in the hyperconjugation. So more number of hydrogen atoms involved in the hyperconjugation, more stability of carbocation is more. Okay, so in this case you can understood inductive effect as well as the hyperconjugation effect. Okay, both will come in this. So which one is the right option? Option B is the right answer. Okay, next question. Reaction with the acidic water is fast. That is acidic water is H3O plus. It can use easily H plus ions. Okay, so first option A, that is ester group. Option B, they are given acetyl chloride. Option C, they are given amide group, acetamide. Option D, they are given derivatives of you can say carboxylic acid. Okay, so see, as you know that if it dissociate, it will react with, if the H plus ions react with, that is CH3, you will get CH3OH here. Okay, it will react with Cl to form SCl. It will react with this group, that is NH2, will form NH3. Okay, here it will react with Br to form HBr. Okay, so which one is the stronger acid? That in that condition the water will reaction of water will be fast here. Okay, so among these, which one is stronger acid? So see the acidic strength here. HBr is more stronger than that of option B, SCl, than that of option A, methanol, than of option C, that is the weakest. It is a basic in nature. Okay, so reaction of water which fast with this group, because here is a stronger acid. Okay, so next question. See the next question. Find out the 3 hydrogen removed by sodium R. They are given the structure. Based on the structures, they are given the alpha, that is alpha, beta, gamma, and delta. Okay, so before you have to understood, first you have to see the acidic order of acidic strength. Okay, they are given some groups which show the acidic nature. Sulfuric acid is the more acidic than that of the carboxylic acid, than that of the phenol, than that of water, than that of the ethanol, then that of the acetylene, then that of the alkyl halide, and last one is the methane. So if you go through this order, it is very easy to understand this question. Okay, so which 3 hydrogens, how many hydrogens are given? 1, 2, 3, 4 hydrogens are there. But what is the question? Find out 3 hydrogen removed by sodium. Okay, so first, according to the priority, that is this hydrogen will remove first, then that of the carboxylic hydrogen will remove, and the other of the last, that is phenol. So which one is the right option? Alpha, beta, gamma. This is the right. So acetylene, it does not remove the hydrogen atom, because the priority of acetylene is less as compared to the carboxylic acid, sulfuric acid, and phenol. Next question. Maximum pKa value. Okay, so they are given 4 options. So first we have to understand what do you mean by pK value. Okay, so higher the pK value, weaker is the acid. Remember, higher the pK value, weaker is the acid. So both are inversely proportional. The value of pK will be less, that is stronger acid. If the value of pK is more, then it is called weaker acid. So among 4 options, which one is a weaker acid? You have to understand. Okay, so see option A, B, C. In option A, they are given carboxylic group here. Option B also there is a carboxylic group is there. Option C also there is a carboxylic group is there. Okay, so but you should remember that formic acid is option A is a stronger acid than that of option C, that is a benzoic acid, than that of the acetic acid. Okay, so in many of exam they asked about this order: formic acid, acetic acid, and benzoic acid. Which one is a weaker acid or stronger acid? Stronger acid is the formic acid, then that of the benzoic acid, and last one is the acetic acid. Okay, so option D. So first this you have to remember. Okay, after that, see option D, again it is called as the picric acid. This is called as the picric acid. Okay, so you know one thing, that is phenol OH. This is not an acid. This is not an acid because it does not react with the base. Reaction is not possible. That's why this is not called as the acid. So here OH group is there. Okay, so in this case it will show the acidic nature only. Okay, it will show what is the acidic nature. Okay, so if we compare, that is the option B and D. Okay, so picric acid is far stronger acid than that of the acetic acid. Okay, so which one is the bad acid? Acetic acid is the bad action. So what is the option? What is the order? So strongest acid, that is the option number A, is the stronger acid, then that of option C is the stronger acid. After that, D option, picric acid, is a stronger acid than that of the acetic acid, and the weakest acid is the B, that is the acetic acid. Okay, which has the maximum pK value. So which one is the right option? Option B is the right option. Next question. Maximum pH is of. They are given 4 options. Okay, so one thing you should remember, the pH and pK value both are directly provided. If the pK value maximum, that is the weakest acid. Okay, if they will ask maximum pH value, that is also they are asking about that is called which one is the weak acid. Okay, so if the pH value increases, acidic nature decreases. In the sense, it is a weak acid. Maximum pH, and among this, which one is the weakest acid, they are asking. Okay, so you know that here a carboxylic acid group is there. Here is a carboxylic acid group is there. Okay, so here is a sulfonic acid is there. Okay, so remember that here is a phenol. So as you discussed earlier, phenol, it is not an acid. Okay, it does not react with base. Does not call as the acid. So 1, 2, 3, these are the acid. So first strong acid is the C. Then that of, if we see the order between A, B, C, C is the stronger acid. Then that of A. Then that of B. B is the what it is the weakest acid, and last acid, that is the option number D, is the weak acid. So this weak acid having the maximum pH. So which is the right option? Option D is the right option. Next question. Reaction is possible. So they given reaction C, CH3Cl plus I minus. So this is the one kind of halogen exchange here. Okay, so see here, incoming group, it is called, all these are nucleophiles. Okay, so this is living groups. Okay, so first of all, you should know which one is stronger acid, which one is a weaker acid. So order of acid they given. HI is more stronger than that of HBr, than that of HCl, than that of HF. Which one is stronger acid? HI is a stronger acid. And which one is a weaker acid? HF is the weaker acid. Okay, so in this condition, one you should remember. Okay, so if the living group, okay, see, if the living group, that is outgoing group, if it forms a good acid, then only the reaction is possible. Okay, so what I am telling this, see, Cl, it is a good living group. Okay, if Cl atom, it is a good living group, it form a good acid, strong acid, then only the reaction is possible. Okay, so if it leaves, it form HCl. Okay, and it form HI here. Okay, option number B, C, here it forms a HCl and it form what? HBr. Here option C, it forms HBr, it form HI. Option D, it form again HBr and it form HCl. Okay, so outgoing halogen, if it form a stronger acid, in that case only the reaction is possible. Okay, so if you see the order, which one is the stronger acid? HI is the stronger acid as compared to the HCl in this case. So this reaction is not possible. Okay, option B, see, HCl is weaker acid, HBr is a stronger acid. So this reaction also not possible. Option C, it form the outgoing acid, it is HBr. HBr, if it is stronger, no, it is a weaker. So HI is a stronger acid. So this option is also wrong option. Option number D, C, outgoing, that is halogen atom, it form a stronger acid. So HBr is stronger than HCl. So outgoing Br, it forms a stronger acid. So this reaction is possible. So option D is the right option. Next question. The basic nature among the following, which one is a good base? What do you mean a base? A species which can give easily a pair of electrons to the other species. Okay, so in these 4 options, which atom will give easily a pair of electrons? That is a stronger base. Okay, so option A, they get primary amines. Option B, it is a secondary amine. Is also primary amines. Option C, that is along with the negative charge present on nitrogen. Option number D, that is example of secondary amine along with that negative charge. So among 4 options, the electron and the atom which contains more number of electron density, that is the stronger base. So here only lone pairs are there. Here there are 2 methyl groups along with lone pair are there. Option number C, 1 electron donating groups along with negative along with lone pair is there. But option D, there are 2 methyl groups are there along with nitrogen content lone pair and negative charge. In sense, in the option D, more number of, that is electron density is more in case of option D. So that is a basic nature is also more. So which one is the right option? Option D is the right option. Okay.